Hey guys, curve sketching. Haha, part 2. It's late and I'm trying to do these fast videos and they're like the ultimate slow videos. Okay, here we go though. Okay, so in the previous video, if you watched it, I just really fast recapped advanced functions and how to sketch stuff. Now we're going to sketch stuff way more accurately. All right, let's do it. So I was talking in the previous video about sketching polynomial functions. So we talked about like end conditions, and that's it, and roots. But we were saying like, oh, wouldn't it be cool if we could find these like peaks, like these local maxes and minimums? All right, let's do that right now. Let's just get that done. So if you want to find a maximum or minimum, also called, which is really important, critical points. We call maximum and minimum values critical points because they're so critical. Or we could also call them extreme values or extrema. Holy, so many different names. Okay, here's something we know. In this course, we learned derivatives. And we learned derivatives are the slope at each point on a graph. So what is the slope at a maximum or a minimum? The slope there is 0. So why don't we find the derivative of this function and set it to 0? And then we can find the exact location of the maximum and minimum values. All right, so I made up a polynomial. That's way harder than the one I did in the previous video. Let's get the derivative of it. The derivative of that will be 6x squared plus 6x minus 36. That's a lot of 6's. Okay, so we got the derivative. All right, now let's set the derivative equal to 0. And then we can find out our max and mins. All right, I'm going to go ahead and divide that whole equation by 6, because 0 divided by 6 is still 0. Then I'll just get x squared plus x minus 6. That makes that a lot easier. So I just divided everything by 6. Now I'm going to factor. All right, what multiplies to negative 6 and adds to 1? How about x plus 3 times x minus 2? Because 3 times 2 is 6. And yeah, that seems good. So therefore, x is equal to negative 3. And over here, x will be equal to 2. So those two spots are where I'm going to have a max or a min. But how do I know which one? Well, we could set up a cool table. Like this one's not too hard. You could figure it out. But before we get into too much crazy stuff, we could set up these tables. And we could look at increases and decreases in functions. Okay, so why don't we do that? So why don't we set up a little table? So like we know our key values are going to be negative 3 and 2. So actually, you know what? I'm just going to sketch this for you. So when x equals negative 3 and when x equals 2, we are going to have a max and a min, or 2 maxes or something. Now I know from looking at this that this is an odd degree with a positive leading coefficient. So I know it's starting and ending in quadrant 3 and quadrant 1. Ooh, why don't we figure out the y values of our maxes or mins? Okay, so let's find the y value of this guy. So let's back to our original equation, f of negative 3. If I sub that into my original equation, because that's what I'm trying to graph, okay, so I subbed in negative 3, and let's just say I do all that math. I get 86. Awesome. That's super easy to graph on my teeny tiny graph. So let's just say negative 3 and 86. Let's pretend that's like 86 up there. So I've got a point here. Hoping that's a max. And let's say I sub in 2. So I find f of 2. So I have sub in 2 times 2 cubed plus 3 times 2 squared minus 36 times 2 plus 5 equals. Say you did that, you get negative 39. Okay, so 2, and let's just like make the worst scale of all time. I'm sorry, make that negative 39. Now, since I know my graph is starting in quadrant 3 and ending in quadrant 1, I know for sure my graph has to be going like this, like for sure. So I can tell right away that this guy is a local max and this guy is a min, just because I know my end conditions. And I don't see another way that that could be true. Okay, so I probably got a pretty good graph right there. Although I don't know any of my x-intercepts. So it'd be cool to find those. Okay, so let's set up a table. Just because we should. So we know that x equals -3 is like a really important value. Some might say a critical one. And x equals 2 is another one. But like, so, but like what's going on in the rest of the sections? So we've got a section here. Let's make this a different color. We've got a middle section where something's going on. And we got this section here of our graph. And in black, we'll just highlight that's the max and that's the min. So I'm basically turning the graph into a table. So I'm say what happens when x is less than -3, and then what happens when x is between -3 and 2, and then what happens when x is greater than 2. So I'm going to make a little table, and I'm just going to use my first derivative, this guy, to like show what's happening. So I know the derivative at x equals -3 is 0 here and here. And since I know it's 0 there, I know my graph is like got a rate of change of 0. It's going to be flat because it's a max and a min. Okay, cool. But what's happening over when x is less than -3? So all you have to do is you just take the derivative 6x squared plus 6x minus 36 and you just sub a value that's less than -3. Like let's just say we subbed in f prime -4. We subbed in -4 into our derivative equation. If you did that calculation, you would get 36. So you would get a positive value. And since you know it's positive, it's going to be the graph is going to be increasing. It's a positive slope. So here's something to write down. You know that your graph is increasing, your function is increasing when the derivative is greater than 0. So if the derivative is positive, your function is increasing. And let's look at our graph. It is. Look, check it out. It's going up like that. It's got a positive slope. Okay, cool. Now let's look at this orange section in the middle. So pick a value of x that's between -3 and 2. Like who wouldn't pick 0? Because I love 0. Okay, so I picked 0. I'm going to sub 0 into this equation and boom, that's an easy one. It's -36. So that gives me a negative value. So my function's decreasing. And check it out. It's going down. Got a negative slope. And then when x is greater than 2, let's pick a value like 3. It's going to equal 36, which is a positive value. So my graph will be going up, like so. So you can use these little tables to kind of show you what's happening in each segment of your graph. Now, what's really key is using the max and min values, the critical points. Using these two critical points as kind of to help you figure out your intervals. Okay, cool. Cool. So that is, I think I might stop here because I've been making really long videos lately. So that's how you can find maximum and minimum values, which we're now calling critical points amongst like 1,000 other names. And here's how you could set up a table and show like increasing and decreasing intervals and to be able to help you graph something. I'll just put in the opposite too. A function's decreasing when the derivative is less than 0. Okay, the end. Stay tuned.